Hello, Y10. I'm going to do a quick review to help you with your exam tomorrow. It's going to be a quick session, just explain the concepts, the basics, and how to solve problems. So you're going to be provided with your formula sheet in the exam, so you have to learn how to practice your formula sheet. Formula sheet includes formulas to do calculations and find out missing variables for Unit 1, motion, and Unit 2, electricity. Anyways, let's get started. Let's start with a very simple example. For example, let's say we have a car that starts accelerating. So when it starts moving from rest, which means the initial velocity is equal to 0, and then the car accelerates to reach a maximum speed. And let's say that maximum speed is about v equals 40 meters per second, just an assumption. And then the driver maintains the speed for a certain amount of time before he sees some obstacles and then hits the brake to stop moving. So at this instant the speed is 40 meters per second. Once the driver hits the brake, the car starts slowing down until it stops moving, so the final velocity at the end is going to be equal to 0 meters per second. Okay. So if you were given the graph, it's much easier to answer these kind of questions. If not, you have to use the formulas provided in the formula sheet. So let's plot this motion into a graph. So we have our horizontal axis, which is the time axis and time measured in seconds. And we have the vertical axis, which is the velocity axis and velocity measured in meters per second. So at the beginning of the motion, the car is stationary and the speed is 0. And after a certain amount of time, the car speed accelerates from 0 all the way to 40. So that's an increase of positive 40 meters per second. And that increase in velocity is going to obviously to happen through time. So assuming that the car has a powerful engine, so it accelerates quickly, and the line is going to be a bit steep. And let's assume this takes about 4 seconds for ease. Okay? So and then the driver maintains constant velocity for a certain amount of time before he sees something and he hits the brake. And depends on how powerful the brakes are and the condition of the road, the car either gonna go slow down quickly. The car either is going to go slow down quickly, or if the brakes are weak or the road is slippery, the car is going to take some more time to stop. So I'm going to assume that the braking force are good as well, and let's say the car stops moving in a time duration of 3.6 seconds. Okay, so to accelerate from 0 to 40, our initial assumption is 4 seconds. And then the driver maintains its speed for a long amount of time, and let's say this is about, 12 seconds. Okay. So if you find your time intervals, obviously in the question you're going to be provided with a graph, and the graph should show something like 4 here, 4 plus 12, that's 16, and here it should be 19.6. So you should be able to read your graph, and your graph is going to be sketched on a grid paper, so you should know each square is equivalent to how many fractions of a second, and by then you can read your time intervals. So to begin with, we can split this diagram into 3 different sections. First section, we have an accelerating motion. So we start answering our question with our SOVAT. So S stands for displacement, which is ungiven. U is the initial velocity, which is 0 meters per second in this case. V is the final maximum velocity, which is 40 meters per second. A is the acceleration, which is ungiven, which can be calculated, and time can be found from the graph, which is 4 seconds. Okay. So substitute on the formula A equals V minus U over T to find the acceleration, and that's 40 meters minus 0 meters per second over time of 4 seconds, and that's a positive 10 meters per second square of acceleration. This means this car increases its speed by 10 meters per second for every second. So 4 times, that's 40 meters per second. Right. and we can find the displacement by rearranging the formula. We have the formula which states that v squared equals u squared plus 2as. So we have the final velocity, we have the initial, we were able to calculate the acceleration. The only missing variable in this case is the s, which stands for displacement. So by rearranging the formula using some simple math, the displacement should be equal to v squared minus u squared over 2a, which is, in this case, if we go back to the graph, v is 40, which is the final velocity squared. So 40 squared minus the initial squared over twice the acceleration, and we get a distance of 1600 minus 0 over 20, and that is a distance of 80 meters. Okay, if we follow the same steps on the last segment of this question, so the first segment, our acceleration was positive 10 meters per second, and it causes increase in velocity. The last segment, the acceleration is not given yet, but it can be calculated from the slope, and a equals v minus u over t, same formula, but in this case the final velocity is the speed when the car stops moving, which is 0, and the initial velocity is the actual speed where the driver start using the brakes, and that's 40, and it took a time of 3.6 seconds. So 0, which is the final velocity, minus 40 divided by 3.6, and if you plug this into your calculator, you're gonna have 10 divided by 0.9, that is 100 divided by 9, that is 11.1 recurring meter per second, and this is a negative acceleration because it causes the car to slow down until it reaches 0 in 3.6 seconds. So if we know the acceleration, we can work out the distance using the same formula, s equals v squared minus u squared over 2a. So the velocity squared is 0 squared, which is the final, minus the initial, which is 40 squared, over twice the acceleration, which is negative 11.1 recurring. Okay. If you plug this data into your calculator, you should get a number which is equal to 72 meters. Okay, right. Okay, so knowing these two, if we had the mass of this car, and an average car would have a mass of something between 1,000 and 2,000 kilograms. So let's say our car in this example has a mass of 1,500 kilograms. And the question says clearly, calculate the force of the engine or calculate the force of the brakes. So we go to the formula sheet, and then we find the formula that links force, mass, and acceleration. F equals mass times acceleration. We have the force given in the question. We were able to calculate the acceleration in both cases, whether it's caused by the engine or by the brakes. And we can find, we have the mass. So, sorry, we don't have the force actually. We have the mass, we have the acceleration, but we don't have the force, so we can calculate the force using this formula. So now substituting your numbers, the mass is 1,500 kilograms, and if you multiply this by positive 10 meter per second squared, which is the acceleration caused by the engine, we get a force of the engine which is equal to 15,000 newtons. Okay, if we use the same equation to calculate the force caused by friction to slow the vehicle down, F equals ma, okay, and mass is the same mass of the vehicle, which is 1,500 kilograms, multiplied by the deceleration rate, which is in this case is minus 11.1 recurring meter per second square, and this is in kilograms, and your answer should be that's 10 over 0.9, 9 over 10, 100 over 9, so that is 9 times 15. The answer should be wait a second, that's 900. You just plug it into your calculator. 9 times 15, that's what? Okay, that's gonna be 13500, should be something like that. Okay, so 13.5 kilonewton, or 13,500 newtons. And this force is negative because it causes the car to slow down. Okay, what else? Oh, there is another way, a much easier approach to work out the distance. And by applying that approach, we should obtain the same results. And how do we do that? We do that by measuring the area under the graph of each segment. So for the first segment, it's a triangle. And if you calculate the area of this triangle using the mathematic formula for triangle, the area of the triangle is half base times height, which is, in this case, for this triangle, is half. Okay, so it's half. Let me sketch the graph again first, so you can have a visualization of what's happening. So to go from 0 to 40 in a time span of 4 seconds, maintain the velocity for a time span of 12 seconds, and then slow down in 3.6 seconds. And the most important thing is, time intervals. So the area of the triangle is half base times height, which is half, and the base in this case is 4 seconds. So that's half times 4 seconds times the height, which is 40 meters per second. Seconds cancel with seconds. Half of 4 is 2 multiplied by 40. That is 80 meters, which is the same as the answer we get in the previous analysis using the equation. Also, we can find the other area. So we have 80 meters here. We can find the other area of this triangle, and that's half base times height, which is half times 3.6 times the height, which is 40. Half of 40 is 20. 20 times 3.6, that is 72 meters, which is exactly the same as the distance we found in the previous analysis using the equations. So obviously, if you have the graph plotted, it's much easier, saves you a lot more time to just calculate the area from the graph rather than using the formulas. Okay, and finally, we still have to find the distance traveled while the car is moving in a constant motion. And this distance is just the area of this rectangle, which is base times height. So it's actually 12 seconds multiplied by the height, which is 40 meters per second. And that gives you 480 meters. So the total distance traveled is equal to the summation of all these three distances, which is 80 plus 480, that's 560, plus 72, and that is 632 meters traveled by the car while accelerating in the first segment, constant motion in the second segment where the acceleration is 0, and decelerating in the last segment where the acceleration is a negative number. Okay, and you need to keep in mind one thing: if the object is moving at a constant motion, meaning that the acceleration is 0, we can use the formula, the basic formula we learned a long time ago, which is speed equals distance over time. And this formula that we're all familiar with can only be used if the object is plotting constant motion or if we were using the average velocity. But if the object is behaving with an acceleration or deceleration rate, so the motion is not constant. So the acceleration is not equal to 0. If the acceleration is bigger than 0, okay, if the, okay, I'm gonna stop here. I'll have to, wait a second. I'll have to adjust the time. So we go time, we go not set automatically. I'll have to change the dates. هنغيره هنديره مثلا okay, my birthday عادي. Okay, let's see what happens now. Is it working? No, it's not working. I'll have to close the app and use it again. Okay, let me see something. Okay, change time region, let's make it even further. And now it's working now. Okay, so if the acceleration is bigger than 0, which is a positive number, and that means the speed is increasing, and if the acceleration is smaller than 0, and that's a negative number, so the speed is decreasing, and we call that deceleration. Okay? Right, so using the formula F equals ma, we can link force to motion using the acceleration. Okay, that's it for this video, and I'll show you another video to help you with electricity soon. Thank you.